Hello, everyone. Thanks for joining us today. I know there's a lot of good talks out there, so we appreciate your time. My name is Joe Dipol. I'm joined by Romain Grecourt, and we work on Project Helidon. And so our agenda today is pretty simple. I'm going to give you a brief overview of what the project is, what it's about. Then we'll go into a little demo. We're just going to show you our quick starts and kind of to see how easy it is to get going with our libraries. And then we'll switch over. We'll do a laptop switch to Romain, who's just going to look at some code so you see a little bit of what coding in Helidon looks like. Okay, so what is this project? We're pretty new. We just released in September. We're open sourced. And simply put, we're a set of Java libraries for writing microservices. So it's as simple as that. We do offer two programming models. So this makes us a little unique. We are an implementation of MicroProfile. So if you're familiar with MicroProfile, you'll know that that's kind of a Java EE style programming model. There's APIs from Java EE. CDI, JAX-RS, and JSON-P being some obvious examples. It's a declarative or inversion of control style programming. As I said, it'll be familiar to Java EE developers. It's been nice to see that this conference this year, awareness of MicroProfile seems to be much greater than it was last year. So that's a good thing to see. And this is MicroProfile supported by multiple vendors, right? So you get some portability here. And I'll talk a little bit more about MicroProfile in a moment. Helidon SE, our MicroProfile support is built on top of Helidon SE. And you can program to Helidon SE directly. And it's more of a micro framework style programming model. So a little more functional, less declarative. No inversion of control. Everything's kind of explicit and simple, a little more like Node.js programming might be. And in Helidon SE, we have some reactive features. And then we're really big on simplicity and transparency. So especially if you program in Helidon SE, no magic, right? We minimize magic. We try to be simple and transparent. So if you look at the Java microservices frameworks out there, and this is by no means exhaustive or scientific. This is just meant to be illustrative. You'll see at the bottom we have kind of small micro frameworks. And these tend to have a smaller feature surface area. They're very approachable, fun to program in, easy to learn, very shallow learning curve. And you'll see a couple listed there. Kind of moving up, then we have a MicroProfile based. So we have OpenLiberty from IBM, and Pyara MicroProfile, Thorntail from Red Hat, and that's where Helidon MP fits in. DropWizard kind of floats around that area too, if some of you are familiar with DropWizard. And then up at the full stack, full featured area, we have Spring and Spring Boot. So again, this is not scientific, but just to give you a little orientation about where Helidon SE and Helidon MP fit. In terms of architecture or block diagram, I mentioned that our MicroProfile support is built on top of Helidon SE. And then our HTTP engine is Netty. And I also mentioned some of our principles. So we like simplicity, we like transparency. We don't do any class loading tricks. There's no special packaging. It's all really boring, straight Java, which we like. So your application is just a Java SE application. That's it. A little more on Eclipse MicroProfile, in case you're not familiar. It was proposed in 2016. That's when it was announced. By these fine companies, and it was a reaction to kind of the pace at which Java EE was moving or not moving, right? The community wanted something a little more agile and a little more aggressive and fast-paced. And so this was announced in 2016. It initially announced some key Java EE APIs to use as a smaller profile of Java EE. But in the 2 years since then, the MicroProfile working group has come up with a number of additional specifications. And so you have those key Java APIs I mentioned there in terms of JAX-RS, CDI, JSON support. But you also have a number of new specifications out of MicroProfile. And so you see them listed there. They range from configuration to metrics and security, health check, fault tolerance, security, open API, open tracing, and a REST client. So the current release of MicroProfile is 2.1. So that was just announced within the last few weeks. And like I said, the community has been very busy over the last 2 years developing new specifications. And then the plan there is the MicroProfile working group will act as like a feeder into Jakarta EE. So it'll be a faster paced incubator, and then sometimes it's likely some of the MicroProfile specs will migrate into Jakarta EE. But the key takeaway here is Helidon is an implementation of MicroProfile, Helidon MP. Okay, Helidon SE, we have 3 main components. So we have the most fundamental of the components, which we call the reactive web server. And if you're writing a Helidon SE application, this is the API you will be programming to most. This is the API you will be using most. And as I said, it's powered by Netty. We have support for open tracing and metrics built into the SE web server. We also have support for these EE APIs like JAX-RS and JSON-P built into the SE web server, and static content as well. So you can serve static web pages. It's not designed to be a static content web server, right? But you can use it for that, to serve some static content. The programming model that you'll see a little bit when we get to the demo is like I said, kind of functional Node.js style. So you will say, here is a path to my resource, here is the handler for that path, right? And you just programmatically do that, right? It's not based on annotations or scanning, it's functional style. The other 2 pieces work along with web server. We have a very flexible configuration framework. It's typed, you can have multiple data sources, it's extensible, and our MicroProfile config implementation is based on Helidon SE config, but you can use it directly. And then we also have security. Now, Romain and I are not security experts, but it handles the standard security things you need to secure REST endpoints, to propagate identities. We have some built-in providers that I list there, including WebToken. We support Google Login, and in fact, in our session tomorrow, we'll be showing that if folks are interested. So I mentioned these 2 different programming styles. These are just very small snippets about the difference there. So you'll see Helidon MP looks a whole lot like a JAX-RS application because it is a JAX-RS application. So that's your standard JAX-RS annotated inversion of control style programming. Helidon SE, on the other hand, you'll see is more functional. So you have routes, and you explicitly declare those routes and define handlers for those routes. We support all the Java 8 language features in terms of functional programming. So Romain will speak more to this, but this is basically your handler is a functional by consumer that takes a request and a response. And so here we just show it being accessed, defined as a Lambda, all right? We're also kind of using in the SE model that fluent builder style programming model that you've all seen. Associated with our project is our CDI extensions, and we actually just pushed these out last week. And so these are a collection of CDI extensions, so they can be used with any MicroProfile implementation. Basically anywhere that there's MicroProfile config and CDI, you can use these extensions. So while they are under the Helidon umbrella, and we'll be focusing on them, you will be able to use these with other MicroProfile implementations as well. And the idea with the CDI extensions is you can kind of define them to take away some of the boilerplate and headaches you need if you had to do this explicitly. So For example, we have support for data source, which means you can inject a data source. And we set up a Hikari connection pool for you. And there's a configuration, a little configuration framework. You just fill out the configuration in a MicroProfile config file for the data source, and you just then inject it. And we have other extensions for the Redis client, for the Oracle Cloud Object Store. This is the OCI Object Store. And we'll be doing more of these as we go along. So this, if you're doing MicroProfile style programming, it's a very convenient way to integrate with various cloud services. If folks are really interested in this, there is a talk tomorrow, I think at 11, Dev 5422, where our coworker Laird will be going over these in detail. And he will also be looking for contributors, right? If you want to write a CDI extension for a different cloud provider, different cloud service, different service, right? That's part of what we hope happens. So these are pretty new. Okay, in terms of the project status, we just released 0.10.4 before code 1. For our MicroProfile support, we are at about 1.2. So we're 1.2 minus JWT support. We have JWT support, it's just not MicroProfile compliant right now. Plus the newer versions of the Java EE APIs. But we have health, we have metrics, we have fault tolerance. Those are all new MicroProfile specs that we have implemented. For Helidon SE, we have the stuff I mentioned. We also have some experimental support for HTTP 2. So we're working on that implementation. Netty has some early support for HTTP 2, and we need to integrate with that. And then we, as I mentioned, the CDI extensions. Some things on our backlog. Getting to MicroProfile 2, we're looking at HTTP clients. So obviously that's important. If you're writing microservices, there's a number of options out there. And we have to decide what we want to recommend or what we want to do in the HTTP client area. MicroProfile 2.1 does define an HTTP client, so we will be implementing that. But with Helidon SE, then what is the recommended client there? And so that's something we have to figure out. GraalVM integration, if you guys haven't heard about GraalVM, Google it. There have been a couple sessions at the conference on that. It's a kind of a polyglot. What is it? The substrate VM can run multiple different languages. Java is one of them. One of the features they have is compiling your Java bytecodes into a native binary, which means you can then run in a container without a Java runtime. So it's pretty interesting technology, but there are limitations and things you need to do. So we're working with the GraalVM team on that. And then we have some other things. We're looking at doing a project starter UI, reactive storage. Open API is upcoming in MicroProfile, and so on. We are an open source project. Those are our various contact points. Go check us out, try us. You'll see how easy it is. If you want to join us on Slack, if you go to our GitHub repo, the top level README has an invitation link for Slack. So you just click on that link, and you can join Helidon users. We are Apache 2. Yay. We were very happy about that. Just before you switch to the demo, a couple upcoming sessions. So we are on the second one there. Our friend Laird is doing one later today. Doesn't have anything to do with Helidon, but it has to do with Kubernetes controllers and Java SE and CDI. So that's kind of an intriguing combination. So that's this afternoon at 4. Tomorrow at 11, we have Laird's talk on the CDI extensions I mentioned, if you're interested in that. Romain and I will be doing a deep dive on the APIs at 12. So we'll repeat a little bit of this talk for context, but then we'll spend a lot more time looking at code. And then I'm just highlighting one GraalVM talk I happened to notice. So if you guys are intrigued by that, go check that out. Okay, so now it's time for the demo. I'm going to do the first half of the demo. We're going to show the Helidon Quickstarts. which are just an easy way to get going. Write your first Helidon application, have it running in Docker and Kubernetes in mere moments. And then I'll hand it over to Romain, who'll show you some code, because he's much better at showing code than I am. All right. So let's see. The first thing I'll show is helidon.io is our website. We have a getting started section, yada, yada. When you go to the getting started, takes you to our documentation. One thing we're really trying to do hard as an open source project is trying to do this right and in a friendly fashion, so we actually have documentation. We have pretty complete Java docs, and so we have a getting started guide. As you would expect, we have two programming models, and right now our getting started, how you do that is you run a Maven archetype. Every time I say that, someone says, what about Gradle? And so we need to document our Gradle support, but if you use Gradle, you can go to our GitHub repo, and the Quickstart examples in the source code contain Gradle build files. So you just can clone that and get started using Gradle. But for now, we're using Maven, and so for this talk, I'm going to be focusing on Helidon SE. That's not because I don't like MP. I love MP, but there's a lot of sessions on MicroProfile here. There's no other sessions on SE except us, our two sessions. So we'll be showing you Helidon SE in our demo. So I'm just copying this, and I'm just going to run. Let's make sure that I'm in the right place and everything looks good, and I'll run the archetype. And as long as the network cooperates, it creates a project. So let's go look at the project. Okay, so our Maven archetype generated this project for you. You'll notice a few things of interest. It's a Maven project, as expected. It has a POM. The POM has everything you need to build and run Helidon microservice. We have source code, yay, one would expect that. We also have a Docker file, all right, that's kind of cool. And we have a Kubernetes deployment YAML file. That's pretty neat too. And we have tests as well. Now, none of this is rocket science, right? This is not new or all that exciting, but again, we like being simple and boring, and we just want to make it very easy for people to build and try our stuff out. Let's see, I will show real quickly, well, let me go ahead and build it first. So I'll build the project, and it will run some tests. Okay, and then it's done. Now, one of the things the project did, you'll see these statements. And what this is doing, it's copying the runtime dependencies into the target directory, and it's copying them to a directory called libs. So we can look to see what's in there. Again, we're all about simplicity and transparency. So this is all the runtime dependencies for this Java SE program that is a Helidon SE application. Okay, gee, Joe, that's great. What about my application? So we also generate for you a jar file, obviously. That is the application code, and actually let's see how big it is. If I could type. Oops. All right, so the jar file, man, I'm really fumble fingering this, I apologize. All right, is pretty small. And I have just a little way to dump the manifest here. And you'll see that in the jar file, we've set up the class path for you. So we've just copied the runtime dependencies into lib, and we've set up the class path. So I know a lot of people think, what about fat jars? What about uber jars? That's where you copy all your dependencies into one jar file. And that's fine. You can do that with Helidon. We prefer this approach, and this has to do about building Docker images. So I'll show that in a moment, but first let's just run the application. So we'll just go here. Okay, so our server's up. This is a real simple application, so I'll just curl it, and it just returns hello world on the greet. There's a couple other endpoints, so I can greet Jose, and we say hello Jose. I can do a put to update the greeting if we want, and Romain will show you this code, put hola. We've updated the greeting to hola, so now if I do hola Jose. Okay, so a real simple application, it works. Nothing too exciting there. So I've run it natively on my desktop. I'll now do a Docker build. Okay, so this used that Docker file I mentioned. That's a part of your project. So it happens easily. You'll also see here, in the Docker file, when it's copying the runtime dependencies into the Docker image, it says using cache. And why is that? Well, that's because I've run this demo a bunch of times on my laptop, and my Docker registry, my local one, already has that layer of runtime dependencies. So this means as I rebuild my image, that the only thing that's changing is that very small application jar file, not my runtime dependencies. So if I was pushing to a remote repository, I don't need to re-push those runtime dependencies, which you would do if you were building a fat jar. Instead, those runtime dependencies are pushed once, and then after that, you're only pushing your application bits that have changed. Okay, so now just to show you, I'm running the Docker image, and we'll do a curl command. And you'll see it works, as one would expect. So I'm going to quit that. And we're going to just run it in Kubernetes real fast. So let's do a git pods. So no resources. We'll do git node. So nothing's running. So I'm running Docker for desktop Kubernetes. And so you'll see nothing's running on it. So using the app YAML that's included with the project, I'll deploy it to Kubernetes, and then we'll do a git pods. And it's up and running very quickly. And so if I get services, then I'll be able to curl it. So you'll see the service is running for it on a node port. So if I just change this port to 3625, then we get back the response. So that's all I wanted to show you on the getting started. And again, the point of this is that it's not rocket science, but very quickly you can go from nothing to a Helidon application running in Docker and in Kubernetes. And then Romain, did you want to take over, show some code?
Yep.
So if we could switch laptops.
Okay.
Beautiful.
So I have exactly the same project that Joe was showing you. I just generated the archetype, and I didn't change anything except the name. So that's why here you see Helidon SE introduction. Before I show you some code, I want to make a point with the packaging. So there's nothing fancy. It's just a Maven dependency plugin. And we are fetching the dependency with the scope runtime and putting them in the lib directory, right? So the point is we're using like a very straightforward concept that everybody is used to, and the packaging is really straightforward. So if you have your own way of doing things, if you have your own plugin that you like, there is nothing that really should prevent you from doing that. So in the case of UberJar, the only thing you need to be aware of is, like every time you make an UberJar, is you need to merge the files that are inside the jars that you would have to flatten, right? So talking about the meta-inf services files, if you have many services that are involved, these needs to be merged properly. If you just flatten them without taking care of these things, then obviously it won't work. So our approach is very simple, and we were basically kind of saying is, if you want to do fancy packaging, it's really up to you. It's just plain straightforward Java. And here you see the way we actually create the class path in the manifest is just, sorry? Yes, my bad. It's okay now? Yep. So we just used the Maven jar plugin. This is a very old technology nowadays. You could just find a lot of documentation of that in Stack Overflow, whatever. So that's it, that's straightforward. And then you can just invoke java-jar in your jar. As long as the lib directory is next to it, it's gonna work. So since it's just a Java SE application, the only thing you have to do really is write a main class. So that's what I'm going to show you. In the main class, we invoke a method called start server, and I'm going to just focus on that for a bit. We do basically two things in that method. We create an instance of the config. Config is one of the 3 libraries that we provide in Helidon SE. Here we are basically creating it with the default static factory method, and that will just pick up by default a file called application.yaml from your class path. So as long as inside your application jar or in your exploded directory, if you're doing a class path from the directory, you have a file called application.yaml. That file will be loaded, and there will be a DOM-like object here, the config object, that will be the root of your config, and then you could navigate through it. So for instance, here, I'm getting a key from the config file, the key server. So if I show you that file that we have, make it bigger. Yes. So we don't have much there. We only have a key for server that I was just showing you, where we define the host and port we want to listen on for the server. And then we have a kind of a application-centric configuration that drives the default value for the greeting. So let's go back to the main method. So here what we are doing is we get the config node for server where we had the host and port. We fit that to a method from server configuration, which will, it's kind of a little bit magic, but it's going to know that you have a config object. It's going to look up the keys, host, and port in there. If you don't want to do that, you could simply use so this is also a builder. You could use this builder, and then programmatically, you would basically set .host.port. You could get the config values yourself, right? This is a little bit more lean and clear for us. So once you set up your web server configuration, then you can create the web server instance. And here is the most interesting part. So what you have to do to create a web server instance is you have to provide the config, so basically the host and port, and then you have to tell it what you want to run in there. And so here, this code will look familiar to you. It's basically what we were showing you on the main slide. So here, what you feed to the web server is something we call routing. Routing is like a registry of basically path and handler. A handler is nothing more than a method that accepts a request and a response and does some processing. It may or may not return a response. So you're going to define your handlers in a specific order, and this will make a chain. Whenever a request comes into the server, we are going to match that chain to find the right handlers that match it. And so several handlers might be called for one request. Some may prepare the work, deserialize some JSON object, for instance, and then there will be a terminal one that will basically send a response. So here, the simple example is basically you could use .get, you pass a path here, /health, and then you define a lambda, which is a by consumer of request and response. So it's very simple. We have a interface called handler, which is a functional interface that is a by consumer of request response. So that simply means that you could either implement it the old-fashioned way, or you could just define it inline with a nice lambda, like we are doing here. And so there is nothing else involved in our chain here, so the only thing we need to do is return a response. So in that case, if you would curl for /health, it would return OK. So the thing we need to look at here now is we provide you a way to organize your handlers in a recursive fashion. So you could define something called a service. And the way you define a service into the route registry is using the method called the register. If you want to define a handler, you would use an HTTP verb here on the routing method. There is HTTP verb, all the HTTP verbs are present as methods. So you could use .get, .post, .delete, or you could also use .any if you really don't care about the HTTP method that's going to be useful here. So a service is, again, a functional interface because it only has one method, and the one method we have is, oh, sorry, I can't show you here. Let's try like this. The only thing it has is one method, which is update, where, again, you're going to define your routes. So this means that from the very top level routing, you could define web service. This service itself could define a bunch of handlers, could define other services, and then recursively, you could basically organize your handlers and your path that way. So let's go back to our application. And the code that we exercised before with Joe is basically implemented in the grid service. Oops, my bad. Bigger, bigger, bigger. OK, so let's focus on the update method. So here, as you can see, we are using the method that take a handler. And instead of using a lambda, we are doing the method reference using the double colon. So that means that we can just define private methods in that class, just accept return void, accept 2 parameters, server request, server response, and then you could just reference them nicely from the one method that you have to implement for that interface. So let's see. We have to show you the JSON support. So like I said before, there is this thing called the handler chain. So the way we provide support for, let's say, JSON is by giving you a service that you will register very early in the chain. That service will process incoming requests, and if it thinks that you want to do JSON for your handler, for your path, say you have accept header that says application JSON, then the service will deserialize the JSON object and make it available for next handlers in the chain. And so the way you would do this, for instance, let's say if my health endpoint, if I needed to consume JSON in there, I would basically do request.content as. And so here it's a little bit important. So the support we provide is basically JSON P. And so what you have to ask here for, it's basically a JSON P object. And so since we claim we are reactive and everything, this has to be asynchronous. So what this returns you is a completion stage of an object of the type you're asking for, right? So here it's a class T. Obviously, I'm passing a JSON object, so it's going to bind the type. And then I can type then accept. It's a lambda, so it's a consumer of JSON. I will call it JSON. Let's see, what did I do wrong here? Nothing. And then over there, I could process my JSON, do whatever with it. But here, I'm just deciding to return the same JSON payload as is in the response. So I would do response.send of JSON. So I said that the JSON support service that we registered earlier was able to deserialize the JSON object for us and make it available through that method. If you want to return payload, it's the same thing, but through the send method. So here we are sending an entity of type JSON object. And the JSON support service basically told the response in the chain, in the handler chain, that it knows how to serialize JSON back. OK. Not quite sure. Is there anything else I need to show, Joe? Forgot.
I think that's the main stuff we wanted to show.
Right. So here you have a few examples. For instance, we support path param, which is pretty standard. So if we look up, you see there is this little template here where you do .get / in curly braces you put your path param, and then inside your handler you could do a request path param. You pass the name, you get the value. And here you see very clearly we are building a JSON object using the JSON P API, and we just pass that to response.send. One thing that is worth noting is your handler executes on the same thread that Netty uses to process the I/O. That means that if you decide to do blocking things or things that are relatively slow, you will consume a Netty thread. So you will prevent your application from processing more incoming requests. So a good practice to follow here is basically to be aware of this, obviously, because you could have deadlocks. And I'm going to show you back this thing. Instead of using then accept because there is a little detail here I could probably show you, maybe not. The completable future, when a future is completed, the then accept method runs exactly on the same thread where complete was invoked. In our case, that thread is a native thread. So if you use this, that piece of code here also runs on a native thread. So obviously, if I have something very slow over there, it's going to consume a native thread. So it's probably not what you want to do. So with the future API, there is also something called then accept async. So you would probably want to prefer that over for a simple use case where you want to avoid starving the native thread. Then accept async by default runs with the fork join thread pool. So if that's suitable for you, you could just do that. Or you could actually just create your own executor service or executor and just pass it straight up to that method to say, I want my consumer of JSON to run on that particular executor. And then the only thing you need to do is make sure that you have your response declared final, that you could use it from that handler, and then you could basically terminate the handler by returning a response.
Yeah, all right. So, excellent. Thank you, Romain. So we kind of showed you today how easy it is to get started writing a Helidon application. Romain showed you some code. So we showed you the basic routing model and how you do that functionally, our JSON support, and how we have support for consuming a JSON payload. If your processing is going to take a long time, you can use that using the completable future API asynchronously. And we'll show more of that in the talk tomorrow if you're interested. Also, if your payload is very, very large and you want to consume it reactively, we have support for the Flow API. So you can get your content as a subscriber.
Right, so maybe I could show you something for that, since we claim we are a reactive web server. So we have entry points to consume the payload reactively from the request, and we have entry points to return payload reactively into the response, right? That's the basic thing. You need to turn reactive when you have payload, right? Either you read payload or you write payload. And so if you see here in the code, you have request content. That class itself, that interface, is a publisher of data chunk. So data chunk is basically some kind of wrapper on the native byte buffer. So that means that here, if you want to consume the payload reactively, you only have to implement a subscriber to that publisher. And then you would be able to use the Reactor framework or your favorite framework that implement reactive streams and do all the fancy reactive things you could think of. If you want to return something that is reactive, the send method also accepts a publisher. So you could produce your own reactive stream publisher and then pass it straight up to that method, and then you would basically return the payload in a reactive fashion. Note that these are for some kind of compatibility reason. This is not the reactive stream API. It's our own copy of the JDK 9 Flow API. So we did that simply because we want to support Java 8. So that means that if you're using another library, you will have to do some adapters between this type. We provide some utility to do that. It's very simple. So for instance, it's very easy to switch from Reactor Flux, and then you create a publisher of this type, and you feed it to the response, right? You just have to import a static method, you do one call, and that's it.
Right, so it's probably worth repeating. So we support Java 8 as well as Java 9 or 11.
Right.
So you can use our stuff with all the features with Java 8.
The Helidon jar are valid Java 9 modules. So you could use that with Java 8, but you could also use that with Java 9, no problem.
Yeah, Java 9 modules with Java 8 bytecode. All right. Okay, and with that, that's done with our prepared content. Any questions? All right, we'll be here for a few minutes. We have stickers. If anyone didn't get a sticker, you're welcome to come up and get a sticker. All right, thank you.